we've talked enough about that. Let's move on to the actual electromagnetism, batteries and electromotive force. Electromotive force, EMF, or epsilon, is actually not a force. I really want to stress this. Even though it has force in the name, it's not a force. It doesn't have units, newtons. It's not a vector. It's a measure of electrical energy, right? It is not a force. So electromotive force is not a force. Magnetic force is a force because as newtons, as a direction, it is a force. Just like friction, just like air resistance, just like gravity, just like whatever. Those are forces. Electromotive force is not a force. It is a measure of electrical energy, and it has units of volts. Just like voltage has volts, electromotive force has volts. Okay. Electromotive force refers to the changing of a non-electric energy into an electric energy. This is very common. You've probably seen this 100 times even today. Some examples, you can turn mechanical energy into electrical energy. Most physical generators, like the most simple one, like a hand crank that makes electricity, or like a motor or like a generator, anything like that, those use mechanical energy because just spinning or other types of mechanical forces, and then they take that mechanical energy and they turn it into an electrical output. That's what electromotive force is, turning from a non-electrical to an electrical. Another very common one that you'll probably see actually more often on the MCAT is a battery. Remember we covered electrochemical cells before. A battery is just the turning of chemical energy into electrical energy, right? Because a battery just has solids like metals, and they produce, when they undergo reduction and oxidation, they produce usually a voltage. They have a potential. They produce some electrical energy when they go through the reaction, right? So you're turning a chemical energy into an electrical energy. When working with a galvanic solid battery, it's very easy to find the electromotive force using the reduction potentials, and we actually already covered that in the previous lecture. If you guys, in the previous lecture where we talked about electrochemical cells, if you remember, for example, I don't remember them off the top of my head, but like copper going into copper 2+ might have, for example, a reduction potential of, I don't know, like 0.7 volts, and I don't know, like zinc going into zinc neutral has a potential of like, I don't know, 0.3 volts or something like that. Like, I'm just giving you examples. Remember how you would find the electromotive force just by, you'd find the reduction potential just by adding up these two. Remember, reduction minus oxidation. So you would use the reduction, which is this one, and then the oxidation is this one. So you just do this minus this, right? And then from there you can find the electromotive force. We covered that I'm not going to go too in depth with that, but I covered that in the previous lecture and much clearer. Okay, that's a very simple way to find electromotive force using for a battery especially, and that's probably mostly what you'll see on the MCAT. There are other ways. These are far more complicated. These are more for like magnetic or mechanical electromotive forces, and one of them is actually Faraday's Law. Faraday's Law is another way to use EMF. It uses a magnetic field and a coil wrapped around a conductor, something that conducts electricity. The equation is shown to the right. It's this one. Epsilon, remember, is EMF. It's equal to number of turns on the coil. So this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13. And then this is a derivative, but essentially just means change over time. Change of magnetic flux over time. Magnetic flux we haven't covered, and I don't think I will cover. it's essentially magnetic flux is it's a magnetic field over a certain like surface area. That's what magnetic flux is. It's the change of flux over time. That's how you get the electromotive force. You don't really have to know that. You really wanted to, you would just have to do the change. It would be like delta, I think it's magnetic field times surface area or something like that. So yeah, so it's more complicated than the MCAT will really test you on. So I don't think they will ever test you on something like Faraday's law ever. The only thing they may ask you to do is they may give you what the change in flux over time is, and they may say, what if we, for example, double the number of coils or triple the number of coils or something like that? What would happen to the electromotive force? And you would have to remember this equation. You'd have to remember this equation. You have to be, well, if the number of coils changes by a factor of 2, that means the electromotive force is also going to change by a factor of 2 or something like that. So yeah, that's the only thing I might expect them to maybe ask you regarding Faraday's law, at least. Okay, next let's talk about different types of batteries. So there's the first type is lead storage batteries. These are some of the most common types of batteries that you find in cars. They're car batteries. They can store a very large amount of charge and provide a very high current for a short period of time. Most importantly, they are rechargeable, so they can be easily recharged. Again, they provide a high amount of current for a very short period of time. Consists of several actual cells. It's not just one cell for this battery because it's so high powered. It's multiple cells connected in a series. In each of these cells, both the positive and negative electrodes contain lead. These are lead oxide and pure spongy lead respectively. So the positive is the lead oxide, and in the negative is just pure lead, just straight old PB. Right, but it's in like a spongy form, but it's just the element PB. They're submerged in sulfuric acid, which is H2SO4. It's also called sometimes a lead acid battery because it's lead in acid, right? After the reaction, both lead electrodes create lead sulfide, right? PbSO4. So that's kind of like the product that gets made, right? And Gordon, actually, I want to note this. This PB is PB2. It's 2+, right? I don't know if that'll be relevant, but just in case, yeah, it's PB2SO4. So remember, just lead storage battery is very simple. Both electrodes made of lead, or lead derivatives, I should say, because it has lead oxide and regular lead, submerged in sulfuric acid. They make PbSO4, and it's multiple cells connected in series. Okay. Next, let's talk about nickel-cadmium batteries, which is another type of battery. It's also rechargeable. It consists of nickel hydroxide positive electrode, metallic cadmium, which is just metallic cadmium is just CD. It's just the elemental CD. It's negative electrode. They're submerged in potassium hydroxide. Sorry. It's not commonly used because it's also kind of like illegal, I think, in certain settings, depending on like what you're using. I think for factories they're allowed, but I'm not sure about the policies regarding this. But cadmium is very toxic to especially the environment and also to people. It's toxic to basically everything that's living. So it's not good for the environment. It's not good for people. So we try not to use cadmium batteries. Yep. It's banned in a lot of things, but it's allowed in certain situations. But yeah, this is just a type of battery. Again, important thing: nickel hydroxide for the positive. For the negative, it's metallic elemental cadmium. and submerged in potassium hydroxide. It's also rechargeable.